Hello everyone, welcome back again. Today we are going to see another important and a very interesting topic. That particular topic is related to again the motion, but here not under constant acceleration, but it is under variable acceleration. So let us see what exactly this motion happening under variable acceleration is to be dealt with, how it is to be analyzed. Let us see ahead. Here you can see whenever a particular body is under variable acceleration, always a problem statement is given in terms of certain equation. So whatever problem we have, it has been defined in terms of a equation. For an example, x is equal to t square plus 8t plus 4. So this is the equation which is giving a relationship between the displacement and the time. Is it okay? So here there are two things. First is displacement, another is time. And we know if I differentiate this equation number 1, so I have velocity is equal to dx by dt. Is that okay? So let us have the differentiation with respect to t of equation number 1. Is it okay? So velocity comes out to be 2t plus 8. So t square will be, as we are differentiating, so t square will be 2t and 8t will be simply 8. Is it okay? So you might have understood that whatever mathematical part we have already studied, that is the differentiation, and maybe at certain time it is going to be an integration. That basic knowledge basically we are going to apply on the motions which are going to be under variable acceleration. Is that okay? So this is how the problem statement is given, and from that problem statement, which is in terms of the displacement and the time, we are going to find out the velocities as well as the acceleration. So just now you have seen how the velocities are being found out. If I differentiate this equation, so on left hand side dx by dt and the right hand side is differentiated in this particular mathematical fashion. Let us move ahead and see how we can find out the further thing, that is the acceleration. We know acceleration is what? It is dv by dt, means equation number 2 is to be differentiated with respect to t. So let us do that particular acceleration differentiation for the acceleration. So here comes out to be, if I differentiate this equation, v equal to 2t plus 8, so here t will be 1, so v equal to 2 meter per second square. Is it okay? So this is the way how we are going to find out the velocities and acceleration when the equation is given in terms of the displacement and time. So what do we conclude out of this? So if the equation of the motion is given in terms of x and t, then we have to double differentiate. With the first differentiation we get a velocity, that is v is equal to dx by dt, and further differentiation of that equation of velocity we get acceleration, that is dv by dt. So this is the only simple thing which we have to perform into the motions under variable acceleration. So here we have seen when the problem statement was given in terms of the displacement and time, there may be a case that the motion equation is given in terms of acceleration and time. So in this particular case, what we did earlier, exactly the reverse thing we have to do here. What we did earlier, we differentiated, means what we have to do now, we have to integrate. Let us see how that particular integration process is to be done. So here we know acceleration is equal to dv by dt, dv is equal to a into dt. So if I differentiate, if I integrate this on both the sides, what I have? So here dv is equal to a dt, a is already defined here. Is it okay? Now we have this particular generalized equation after substituting the value of acceleration in the new formed equation. Now what we have to do? We have to integrate it both the sides. So integration of dv is equal to integration of 3 minus t square dt. So if I perform this particular integration, you know what we are going to get. Left hand side integration of dv will be equal to v, and integration of 3 minus t square will be 3t minus t cube by 3 plus c1. So here whatever integration we are carrying out, it is limitless, doesn't have any lower limit and the upper limit. So what we say this as a indefinite integration. So there always occurs the constants. Now as far as these constants are concerned, these constants are to be found out from the given boundary condition in that same problem itself. Is it okay? Certain conditions will be defined under which the motion is going to be performed. So according to those particular conditions, we are able to find out this constant C1. So by substituting that, we can find out that particular constant C1. Is that okay? So this is what we have. We have the equation of motion in terms of A and T. By integrating it, we got the velocity. Similarly, if I got to know the displacement, what we have to do? We know V is equal to dx by dt. Is it okay? Now here V is equal to dx by dt means what? Dx is equal to V into dt. Is that okay? Now I can do the integration for this. So integration of dx is equal to integration of V into dt. As far as this particular V is concerned, this V we are going to get from here after finding out the constant value C1 from the boundary conditions. So this value of new V will be substituted here, and here left hand side is integration of dx. So integration of dx will give you x. As far as the right hand side is concerned, it will be coming along with the second constant of integration. Again this constant is to be found out from the various boundary condition which will be given in the problem itself. Is that okay? So this is how we have to do the integrations and the differentiation. So whenever the motion equation is given in terms of x and t, there we have to differentiate, whereas in this particular case equation was given in terms of a and t. So here I have to perform the integration, and always remember this integration is a indefinite integration, so it will always carry the constant which is to be found out from the given boundary condition in that particular specific problem. Is it okay? I hope the understanding is getting into this particular problem, that what is to be done under which situation and how these values of constants are to be found out from the boundary condition. Definitely we will be taking many problems from which we shall be able to find out the exact solution of the problems which are under variable acceleration. So here let us see certain numerical. So here is the first problem. The position of the particle which moves along a straight line is defined by x is equal to t cube minus 60 square minus 15t plus 40, where x is given in terms of meter and t is in the second. We got to find out the time at which velocity will be equal to 0, and at that time what will be the position and distance traveled by the particle. Similarly at that same time acceleration will be how much, and the last one is distance traveled by the particle from t is equal to 4 second to t is equal to 6 second, right? So here let us have the equation of the motion, that is x is equal to t cube minus 60 square minus 15t plus 40. Now we know that if I got to find out the velocity, what we have to do with the displacement equation? We know velocity is equal to dx by dt, means we have to differentiate this equation number 1 with respect to t so as to get the velocity. So here comes equation number 2, which is defining the motion in terms of velocity and time. Similarly we can find out the acceleration by once again differentiating this equation number 2, that is acceleration is equal to dv by dt. So here are the three equations which are defining the motion in terms of displacement and time, velocity and time, and acceleration and time. Now here let us take one by one what is required. First is what? Time at which velocity of the particle will be equal to 0. Here we are speaking about the velocity, means we have to take equation number 2. Is it okay? So take the equation number 2 where velocity should be equal to 0, means we have to substitute the value of v equal to 0. So here equation number 2, here v is equal to 0. I am having a quadratic equation, and solving that quadratic equation I got t equal to 5 second, and another value of t was in negative, so I have eliminated that particular negative value. So this is what is the time where the velocity will be equal to 0. The second thing which we have to find out is the position and distance traveled by the particle at that time, means at t is equal to 5, what is the position and distance traveled by the particle. As far as the position and distance is concerned, it is related to the displacement, means we have to take the equation number 1 and put t equal to 5 in that equation number 1. So let us have this. So we have t equal to x is equal to minus 60. Is that okay? So here at t equal to 5 second, I got displacement is equal to 60 meter. So initially we have found out the time at which velocity is 0. Now we have found out the displacement at that particular time. The third thing which we have to find out is the acceleration at that particular time, t equal to 5 second, means we got to take equation number 3 and substitute the value of t equal to 5. So after having this simplification, we got acceleration is equal to 18 meter per second square. So out of 4 we have found out all the first three. Is it okay? A, B and C. In order to find out position or that particular D point, let us see what is the necessity of this particular point number D. Is it okay? So here it has been asked to find out the distance traveled by the particle between time interval t equal to 6 second, but I cannot simply put the value of t equal to 4 second and t equal to 6 second in equation number 1 and find out, because it is a time interval. So if I have to travel from t equal to 4 to t equal to 6, means I have to move from t equal to 4 to t equal to 5 and t equal to 5 to t equal to 6. So in between there are certain displacements to be found out. So we have to find out the displacement at t equal to 4, t equal to 5 and t equal to 6, and that is to be substituted for finding out the total displacement traveled by that particle in between t equal to 4 to second, and this is this particular equation. So x6 minus x5, it is taking in the mod section. Is it okay? And x5 minus x4, as you can see, 4 to 5 and 5 to 6. So in between whatever difference we have, that is going to give you the total distance traveled by the particle. So we know velocity is 0, t equal to 5 second. So at t equal to 6 second, t equal to 4 second, and also we have to find out the displacement at t equal to 5 seconds. So we got to find out that one by one by simply substituting the value of t equal to 4, 5 and 6 in equation number 1. So do the simplification. So I got x6 is equal to minus 50, x4 is equal to t cube minus 60 square minus 12t plus 40. Is it okay? So after substituting I got this, and if you have seen it carefully, x5 is equal to what? Minus 60. Actually this value was been already found out here. Is it okay? I could have directly picked up. So anyway, so after getting the value of displacement at t equal to 4, 5 and 6, substitute in this equation. So we got d equal to 18 meter. Is it okay? So this was the prime objective of this particular problem. So always remember, first of all, whenever the problem will be given, try to understand the equation of motion, in what term it has been given, and accordingly we have to decide whether it is the differentiation required or integration required. Is that okay? So here simply by doing the differentiation of the displacement velocities, we found out the required parameter for this particular problem. Is that okay? So this is how we have to solve the problem.